So in this class we're going to be using Java to develop games. Now there's a lot of languages out there, and some of them are more suited to games, some are less suited to games. Java is one of those that is less suited to gaming, and it's just the nature of the way the code is set up, compiled, and it executes and everything like that. It's not the most speedy programming out there. So it doesn't always lend itself well to games. That being said, there's lots of games out there that do exist in Java. They just may not be as intense as other games in terms of processing and whatnot. But suffice it to say, we will be using Java. We chose Java for this course for a number of reasons. Gaming was not one of them, but ease of access and ease of usability. It is one of the most used languages on the planet, if not the most used language on the planet. For various reasons, in one form or another. But we are going to use it for Java game development, so here we go. The way that we're going to do this is that the teachers of the course here, myself and Mr. Finley, we took the time and we created a small game engine to help you along the way. A game engine is just basically a set of tools or libraries that have a bunch of pre-built-in functionality to allow you to do common gaming concepts, things like loading images, sounds, animations, things like that. Relatively straightforward concepts. Now, in our case, what we've done is we've built a project which you can go on to the course website and download this base project called Java Game Project, and it has the engine set up inside of it already, and it's ready to go. What we did is we actually used Microsoft's XNA as a model when we designed this, so it does mimic that setup to a degree. So basically what we're going to do here in this lesson, I'm going to walk you through how to use this Java Game Engine project. So once you've downloaded it, unzipped it, and imported it into your workspace, you should be looking at a screen similar to what you see on your screen now. And we're going to go through all the little pieces here to make sure that everything is set up, ready to go, and you understand all the pieces. Now, if you're looking at this, it's quite a bit more intimidating than your standard Java project when you first create it. There's a lot going on here, some of which you're going to touch, some of which you're going to leave alone, but let's see if we can get through all the pieces. So the first thing, we'll start at the top and we'll work our way down. The first thing up at the very top is our libraries. Now these libraries there's a few more than you normally see. These are the main ones that are part of the engine that we've set up, but there are a few others that we do take advantage of, and they all need to be there. So when you create this game project, you're going to be working in your main.java, as we see here, and if you start adding more files, then you may need to include this stuff as well, just to make sure everything will work in all the files, but it depends on what you're doing in those other files. So anyways, so those are our libraries that need to be there, and below this we get into the main, which is the same that you're used to. This is our class main. Don't worry about what it's doing here in terms of the extends and stuff like that. That's just the built-in logic of the game engine that we've set up, so you're not going to touch that. All of this global data up here, this is all data to help set up the look of your game. So if I run this program right now, let me just run it, hit OK. What we get is a standard 800 by 600 window with a black background. This is actually a game that is running. There's just nothing going on. So what we see up here is a few pieces of data. The graphics device is basically that window that you're looking at. It's a place where we're going to be drawing everything. The screen width and screen height, it actually detects the full width and height of your screen itself. Down here, this is required basic game visual data, as it says. This is where you're going to make modifications. This is the first place you're going to make modifications to your program. So what do you want to name your game? So my game, if I run this program again, we'll see my game shows up in the title bar there. So if you change the name, it's basically just going to change that value there. Window width and window height. So right now I have it set at a standard 800 pixels wide by 600 pixels high. You can modify this if you want. If you want it to be full screen, just use screen width for the 800 and use screen height in place of the 600. That'll give you the full screen. Now you've already listened to all the modules on game loops. Well, here's your FPS counter, your frames per second. So our game loop is, by default, we're going to have it run at 60 frames per second. You may want it slower, you may want it faster. All you have to do is change this value and it will update automatically. Now remember, use this with caution, use it sparingly. You don't want to set it at some ridiculous number, because mainly it's probably not going to be able to process at that ridiculous number. And if you recall from our previous videos, the eye really can't see anything above 150 FPS. So anything more than that, you're just kind of wasting your time in terms of visuals. There's other arguments behind that to use that for other reasons, but for now, you're probably not going to want to go much higher than 60. You may want to go lower. You may want to go down to 10 or 12 or 15 or something like that, depending on what you're doing. A lower frame rate means that it's easier to use animations that have less individual sprite frames in them, but we'll get into that later. The main section, which is what you're used to working with, you're actually just going to leave this alone. This basically sets up the game engine, that window that's going on there, the game window, and draws it with all the data that you've set up here. Okay, so just leave this main alone. So that's going to be untouchable. The three parts you are going to work in are load content, update, and draw. Load content is the base thing that happens in your program. It's the first thing that happens in your program in terms of getting things up and running. It happens once per game, so it happens at the very beginning before the game loop starts. This is the place where you're going to load any images, media of any kind, maybe set up some starting values, set the user's score to 0 or something like that, depending on what you're doing in your program. So load content is super important, and it's where you set everything up. All right, all your images, everything. Once load content is done, the game loop starts. And as the game loop starts, as you remember from previous videos, it basically goes back and forth between update and draw. So every cycle of the game loop, it says update and then draw. Well, what are we updating? We're updating all the game logic. So we're getting user input, we're handling movement, physics, collisions, AI, sound, everything involved is handled right here. Now there is some pieces of data here that may be useful. This delta time is a float, and it tells you, measured in milliseconds, how much time has passed since the last time this update code has executed, which is very useful in terms of animation. So you could say, or like moving things around the screen, you could say, well, this much time passed, so it should move this far, right? So you can use that to your advantage. It's not available everywhere, but it is set up. The game engine will give you how much time has passed for this area. So the update, this is where you do all your logic of your program. Now you're probably not going to write it all here, because that'd just be bad style. Once you get into learning subprograms and whatnot, if you haven't already done so, you should be breaking up your program into subprograms and then calling those subprograms there. So that is your update. Finally, we get into the last piece of the puzzle, which is draw. Remember, it's update, draw, update, draw, update, draw, 60 times per second by default. So draw, as it says here, the only logic here should be selection logic. The only code that really should be in here is draw commands, right? Maybe you're drawing a rectangle, maybe you're drawing an image, whatever you're drawing. But that's the only logic that should go here. The only exception to that is you may have an if statement that decides what to draw in a various circumstance. So for example, if you're in the main menu, you only want to draw the main menu stuff. You only want to draw like the options that they have and things like that. You don't want to draw the gameplay. You don't want to draw the end of game screen or anything like that. So the only logic you're going to have here in draw is maybe an if statement that says, if I'm in main menu, then draw main menu stuff. Otherwise, if I'm in gameplay, draw the game. Otherwise, if I'm in top score, draw the top scoreboard. That kind of stuff. So that's the only logic we should really see in there as a whole. So this project basically simulates a game loop, as I said before. Your job is just to fill in all the logic, mostly in update and draw, and probably in load content as well. So there are a few things that I need to caution you about. Now remember, because your program is running at this frame rate, in this case by default 60 FPS, 60 frames per second, these two subprograms, update and draw, are actually going to execute 60 times per second. So one thing that we typically do when we're making games, because of this game loop happening so often, is we try to avoid common problems that can slow down the CPU. Number one, you should try and avoid creating new variables inside of update or draw. They should probably be created globally for this case. Now I know in our normal programs we try and keep everything local, and we're still going to try to, but for the most part what's going to happen is you're going to need global data throughout your program, but just because of the nature of it. You don't want to be redefining it 60 times per second. It's going to vastly slow down your program, which is not going to allow you to achieve the results you're actually expecting. So that is the main game engine and everything that we can do in here. Now that being said, there is another object that you guys have access to, and that's what's called the helper object. So just like the math library, you could say math.pow or math.square root, that kind of stuff. The helper library also has a ton of options. So just to show you some things, if I type in helper here and then hit the dot, you can see that literally there is a truckload of different options here. The first thing you see is a bunch of colors. So you may be drawing certain maybe shapes or whatever you're drawing on your screen. These colors are where you're going to get the where you're going to set that up. So you might say helper dot. Oops, where'd it go? You might say helper dot black. And so when you go to draw it, it'll draw it as black, right? So those are basic colors. Now that being said, maybe you're not happy with the 15 or so or however many colors that we have preset for you. Maybe you want to create your own. Well, you can. Using the get color commands, you can actually specify your color using red, green, and blue. And you can even specify a transparency if you want. So maybe I want something like this. Get color. Let's use this one. Now what it's saying here is if I put my mouse over top of here, it will give me a little tooltip of exactly what my options are here. So I specify my red, green, and blue in values between 0 and 255. Similarly for the transparency. And then that'll allow me to create that color. Now if I'm going to create it, I should probably store it. So I might say like color back, let's say BG color, so background color equals helper.getColor, and maybe I want it to be a nice pretty blue, slightly greenish one. So maybe I have a value of 0 for red, maybe, I don't know, a value of 50 for green, and 255 for blue. So it's much more blue than it is green. And then I can set my transparency level. So how opaque do you want it to be, right? So from 0 to 255. So when you get to 255, that means that it is fully opaque. It's not transparent at all. If you want partially opaque, then you need to go somewhere between 0 and 255. So you might say like, I don't know, 100. And that should be, yeah, that's good. And we got to end with a semicolon. So that's one of the options we could use for creating our own colors. Now the helper can still do a lot more. So if I scroll down here, you can see there's a number of other options. Down here we have a random value option. So you can actually generate a random value. It's already pre-built in here for you. So you just have to say, I might say something like this, float num is equal to helper dot random value, and I need, let's say 1, 10. That is going to give a random value between 1 and 10, including 1 and 10, and store it into num. Notice that num is a float. If you want it to be like an integer or something like that, then you would have to cast this to an int, and then that would actually work out just fine. You would just lose any decimal places, but since you're generating a whole number between 1 and 10, that really shouldn't be an issue. So that's the basic stuff from helper, but there's actually some really complex stuff in here as well. So if I type helper dot again, you'll notice that there is a truckload of these intersects commands. And that's because there's a whole bunch of different types of intersecting. So intersects in games means that two objects are touching one another. So for example, if you're making a shooter game, one object might be a bullet and the other object might be a player or a wall or something like that. So what we want to do is we want to test to see if they're touching or intersecting. If they are intersecting, we cause some type of game action. So it might be like an explosion or a particle system or something like that. So you can see that we have a ton of different options set up here, and all you have to do is specify all the information you need. So for example, we go down here, this test to see whether two rectangles are colliding. Down here we have a box and a point, a single point. At the very bottom we have a cone and a point. This is, a cone and a point. And the purpose behind this is if you're making a game that has like a stealth game or something along those lines, where your enemies have a field of view, a field of vision, like a cone of vision, and you want your player to avoid that cone. This will allow you to test to see whether the player touches that cone or whatnot. And all of these intersect subprograms return a true or false. That's it. They just return a true or false. And if it's true, they're touching. So you handle that in what you best see fit in your programs. So as you can see, the helper is very, very versatile. And I believe, yeah, that should be about it in terms of everything there. So that is your GameLoop, and sorry, not your GameLoop, your game engine, and what you can do with it. Hopefully a lot. That's it for now.